Hello and welcome back to one more session of grade 10. Today we are going to discuss about the chapter trigonometry, and as the name says, it is not trigonometry, introduction to trigonometry. It's only introduction, the word is actually trigonometry. So this is a very important chapter as far as your not only your board exams are concerned, but also for your 11th and 12th. Actually the basic of grade 12th, trigonometry comes in grade 11 actually. This is just an introduction, it's just a tip of an iceberg actually. And for those who intend to learn math hereafter, there is no math without trigonometry. Not only math, physics and all your wave equations or like satellite navigations or any kind of such study. Basically, it's all trigonometry everywhere. So you don't stand a chance without trigonometry if you want to go to the higher classes. So let us see what do you mean by trigonometry. Then we'll come to introduction to trigonometry. In fact, the word trigonometry actually it's self-content. It's self-content because the word itself says what it is. It comes from two words. One is trigon plus the other word is metron. Trigon plus metron gives you trigonometry. What is meant by trigon? Trigon means nothing but triangles, and metron means measure or science of measurements or study of measurements. So triangle and its measurement together gives you trigonometry. Why triangle and its measurement? Now for example, when you look at a triangle, when you look at this triangle, just I'll put up another one. When you look at this triangle, oh my god, it's going weird. Okay, there to come. When you look at this triangle A, B, C, I suppose it is right angled at B. Now when you look at this, you know this is 90 degree and this is maybe little less than 90 degree, maybe approximately 60 or so, not exact. This maybe I can take it as 30, anyway smaller. This is the smallest angle, this is the next smallest, and this is the largest angle. When you look at the corresponding side, this is the shortest side, next shortest side, and the longest side. So the longest side lie opposite to the largest angle, and the shortest side lie opposite to smallest angle. So this is the story. That means this means that longer side opposite to the larger angle, shorter side opposite to the smallest angle. That means there is a relationship between the sides and their opposite angles. So this is what actually trigonometry explores about. Okay, so triangle and its measurements. What kind of measurements? Measurements of the sides and angles. Obviously the area also comes. There are a lot of things coming like that. So now the next question is, why trigonometry? Why trigonometry? I say trig, just between you and me. Trig. Why trig? Trigonometry. Why trigonometry? What is the use of trigonometry? I'll just put up just a slide there, a small picture. It shows that, like, I'll just put this one. Okay. It's a picture showing the mummy. The pyramids of Egypt. You can see that there are a lot of triangles involved in that. So this pyramid is rich in triangles. That means there are a lot of measurements, there are sides, angles, a lot of calculations involved in that. That means that trigonometry has something to do with mankind, right? It's all, pyramids are all old stories. Let us look something new, or which is required in our real life. Let us look at this picture. This is very important in our day-to-day life. I just put up the picture of, that's just a building there. Can you see that? It's just a building or a tower or so, something like that. What is the advantage? Suppose you want to find the height of the the figure, the picture or the tower or something, and you are positioned here. This is your position, and you have a clinometer. Clinometer is an apparatus to look at a particular angle, and this angle. You calculate this angle to be 60. Suppose we need to know the height of this. What you just need to know is that you just need to measure this distance. That's easy, right? Measure this distance. That is, you need to measure the distance from where you are standing to the foot of the building. that makes a relationship. Trigonometry teaches you a relationship between these two, and that helps you to find the height of the building. That means, simply speaking, when you look at the triangle building, you can find the height of the building. I mean, I swear you, right? I swear you. It's not bluffing. When you look at the height, when you look at the at building, you can calculate the height of the building. Obviously, in this chapter we will see, or in the next chapter, there is a chapter known as heights and distances, application of trigonometry. There we will be doing such questions. In fact, that's it helps. Trigonometry has a lot of use in our day-to-day life. So, in order to begin with the chapter, I already said that in a triangle, there are already certain measures. Now let's consider a right angle triangle. A right angle triangle, name it as ABC. A right angle triangle. Okay. Now, when you look at this is the smallest angle in this. When you look at this angle, there are sides for this angle. As far as angle C is concerned, I will say AB is its opposite side. Right. What is BC? If this is opposite, it is directly opposite this side. This is not opposite, we call it as adjacent side. And AC is unique because it is opposite to B, therefore it is hypotenuse. So, as far as any angle is concerned, let us look at angle A. As far as angle A is concerned, BC is the opposite side. BC is the opposite side. And what about AB? AB is the adjacent side. And AC is always the hypotenuse. So, this relationship between the angle, whenever you take an angle, there is an opposite side and adjacent side. Opposite means directly opposite, adjacent means one of the side which makes the angle. And in being in a right triangle, the third side will obviously be hypotenuse. Okay, this is the story. So, now let us start the chapter. Okay. So, in order to start this chapter, we start the discussion with something known as trigonometric ratios. Trigonometric ratios. So, now let us consider a triangle. We call it as A, B and C, or we will name it in a different way. Why always A, B, C. It's all fine. Right angle at B. Let us consider angle. Consider angle A. As far as angle A is concerned, what is BC? What is BC? BC is its opposite side. And AB is what? Its adjacent side, and AC is hypotenuse. So, this is the hypotenuse, this is the opposite side, and this is the adjacent side as far as angle A is concerned. Now, for this we define certain trigonometric ratios. We define the following ratios. Why ratios? That means, suppose I extend this triangle. I'm making different triangles here. Okay, I'll get different triangles. There are a lot of triangles. Right, I'll put up another figure there. There are a lot of triangles here. This is angle A, B, C, D, E, F, H, P, Q, and everything. There are different right angle triangles. One is ABC, the other one is DE, other one is AF. There are all right angle triangles. Now, when you look at these angles, you can see that this, there is a distance for this, there is a distance for this. This distance is larger, and obviously this distance is larger. This is much larger, this is larger, right? So that means some certain relations are there happening between in such triangles. Now we define, listen here, we are going to define certain trigonometric ratio. We define the following ratios. Okay, we define the following ratios. First thing is, we call it as sine of angle A. Sine of angle A. What is sine of angle A? The sine of angle A is a ratio of two things. One is its opposite side by hypotenuse. Opposite side by hypotenuse, BC by AC. Should remember by opposite side by hypotenuse. Okay, adjacent side by, some say that O by H and all, opposite side by hypotenuse. We call it as sine of angle A. In short, this is written as SIN, sin, not sin, it is sine, sine A. We call it as, please be careful, not sin, it is sine A. Next one, we define, this is opposite side by hypotenuse. We call that ratio as, when you look at these triangles, opposite, as far as this angle is concerned, this side by this side by this side by this by this, all those things will be, those ratios will be equal. That is the concept. I'll leave it. Now we come to the next ratio, that is adjacent side by hypotenuse. Which is that adjacent side? That is AB by AC. Adjacent side by hypotenuse. We call it as cosine of angle A. Cosine of angle A. Simple is COSA, cos A. Cos A, I repeat, cos A. That means this by this by those. That is, those who are interested a little bit, I will put up it here. That is AB by AC cos. That is same as this distance by AD by AF. That ratio remains constant. That is the meaning of trigonometry. Now we go for the next ratio. The next ratio is opposite side by adjacent side. That is, opposite side is BC, adjacent side is AB. Opposite side by adjacent side. We call it as tangent of A, or short is tan A. Tan A. Tan A. Next one is, I copy that figure. I'm just copying this figure. I'm copying this figure here. Okay. Okay. Now the next ratio is reciprocal of what we wrote. I'm making different ratios with reverse from here. I'm going reverse. This is opposite side by adjacent side. Adjacent side by opposite side. That is AB divided by BC. Adjacent side by opposite side. We call it as cotangent of A. The first three letters COT, cot A. Cot A. Now we are going back reverse. Okay. The next ratio is the reciprocal of this. Hypotenuse by, we are making all the possibility. First we took this by this. Okay. These two by this. Then this by this. Then these two. All possible combinations. Hypotenuse by reciprocal of this. Hypotenuse by adjacent side. That is, hypotenuse is AC divided by AB. Hypotenuse by adjacent side. We call it as secant of A. secant of A, or short is sec A, not sec A, sec A. So the often wrong way of telling it is sec A and all. Sec A, secant of A. And the last one is hypotenuse by opposite side, that is AC divided by BC, that is known as cosecant of A. Cosecant of A, short is cosec A, cosec A, cosec A. So I just sum up that, it's given there, the details are given there. Sin A, side opposite to angle A, that is opposite side by hypotenuse. Cos A, adjacent side by hypotenuse, opposite side by adjacent side. Secant A, cosecant, all the details are given here. Okay, so this is what we mean by the trigonometric ratio. So I'll sum up that once again. I'll sum up that. I'll write sin of A, nothing but opposite side by hypotenuse. Cos A, this is what you have to learn. Cos A, adjacent side as far as any angle is concerned, adjacent side by hypotenuse. Tan A, opposite side by adjacent side, opposite side by adjacent side. So it's very easy to learn. Now the reverse, we call it as cot A, the reciprocal, adjacent side by opposite side. Learn it now, the reciprocal of this, call it as sec A, not sec A, sec A, hypotenuse by adjacent side, and cosec A, that is hypotenuse by opposite side. So this is the basic trigonometric ratios. These are the basic trigonometric ratio. Now when you look at these two things, we can see that what? Cot of A is equal to what? Reciprocal of this, that is adjacent side by opposite side, that is the same as 1 divided by excuse me, 1 divided by opposite side by adjacent side, that is same as 1 by tan A. So this is very important to learn that. It is very important to learn that cot of A is equal to 1 by tan A. Tan A. Similarly, when you look at these two, what are the adjacent side? Hypotenuse. Hypotenuse side. Secant of A, sec A, 1 by what? Cos A. And the last, when you look at these two, cosecant of A is equal to 1 by sin A. These are the relationship between the interrelationship between the trigonometric ratios. You can see that it is given the reciprocal ratios. Sin A is equal to 1 by cosec A. That sin A is equal to 1 by cosec A. Tan A is equal to cot A is equal to 1 by tan A. These are all for tan A is equal to 1 by cot A. So you should learn it now and now itself. That is, you don't have a second chance. That is, I repeat the whole thing. That is sin A, and cosec A are reciprocal. Tan and cot are reciprocal, and similarly cos A and sec A are cosec. Simply speaking, we say sin and cosec, and tan and cot. Without angle, we can say tan and cot are reciprocal, and cos and sec are also reciprocal. When you look at this, it is evident here. Sin A and cosec A, they are the reciprocal of one another. Sin A and cosec A, cos A and sec A, cot A and tan A, they are reciprocal of one another. From this we can write one more thing. What is that? Tan A is equal to 1 by cot A, cos A is equal to 1 by sec A, and sin A is equal to 1 by cosec A. This one is the reciprocal of the other. So that's what We are going to start small simple question. Before starting the questions, I'll just say once again, we are defining 6 trigonometric ratio based on the we are taking various ratios between the sides, opposite side and adjacent side, one ratio, opposite side hypotenuse another ratio, hypotenuse adjacent side another ratio. So we are creating certain ratios and we name them. First one is as far as any angle is concerned, opposite side by hypotenuse, we call it as sine. Opposite adjacent side by hypotenuse, cos. Opposite by adjacent, tan. Then the reverse, adjacent by opposite, cot. All the possible combinations. Okay, and we name it accordingly. Now as far as any another triangle is concerned, we are taking another triangle. Okay, let us look at this triangle. Name it as A, B and C, or P, Q and R. P, Q and R. Suppose this is 5, sorry, this is 4, this is 3. Obviously this will be 5. Pythagoras there will be equal to 5. So as far as angle R is concerned, what is sine of R? Sine of R is opposite side by hypotenuse. What is that measurement? Sine R, opposite side. What is opposite side? 4 divided by 5. What is cos of R? Cos of R is adjacent side by hypotenuse. As far as R is concerned, which is this is the opposite side, this is the adjacent side. So 3 by 5. Tan of R, that is opposite side by adjacent side. Opposite side by adjacent side, 4 by 3. Cot R, the reciprocal, adjacent by opposite, obviously 3 by 4. Sec R, secant of R, hypotenuse by adjacent side. No, we know that, sec is the reciprocal of cos, therefore 5 by 3. And the last, cosec R, obviously 5 by 4, reciprocal of sine, and it goes like that. Okay, so now we are taking a small question. The question says, in a right triangle, question says that in a right triangle, right triangle, oh, there is something missing here, the figure, this is missing. We can read the question itself, here itself. In a triangle ABC, right angled at A, right angled, in triangle ABC, right angled at A, if AB is 12, AC is 5, BC is, find all the trigonometric ratios. Simple question. Question is very simple. That is, triangle ABC is question number 1. Question number 1. In triangle ABC, right angled at A, triangle ABC, right angled at A, B and C. Question is, find all 6 trigonometric ratios of angle B. 6 trigonometric ratios of angle B. This is the angle that we are under consideration. So what is this? This is the opposite side, this is the adjacent side, and this is the hypotenuse. AB is equal to 12, this is 12. AC is equal to 5 centimeters. So we have, and BC is equal to 13. It is already given. You have to find the measurement of all trigonometric. First one is sine of B, that is opposite side by adjacent side, 5 by 12. Second one is cos of B, opposite side by, I made an error there. opposite side by hypotenuse, that is 5 by 13. Cos B is equal to what? Adjacent side by hypotenuse, that is 12 by 13, and tan of A is equal to opposite side by adjacent side, that is equal to 5 by 12. Now cot of A, that is adjacent side by opposite side, that is the reciprocal of this, so that is equal to 12 by 5. Sec A, reciprocal of this, hypotenuse by adjacent side, 13 by 12, and cosec A is equal to hypotenuse by opposite side, that is equal to 13 by 5. We got the 6th trigonometric ratio. Question number 2. What does question number 2 says? If cos theta is equal to theta, what is that? Theta comes from, theta is just a theta. What is theta? You all know that. What is theta? It's a Greek alphabet. That's Greek alphabet used to denote theta, I mean angle. Well, not only angle, we often angles are denoted, but various purposes. It is given that question number we will take at question number 4, not 2, question number 4. The other things are very simple, you can do. Cos theta is equal to 8 by 17. Find all other trigonometric ratios. So in this we draw a triangle, a right angle triangle, because the trigonometric ratios are defined for right angle triangle. Okay, and we take one of the angle, either you can take this as a theta, ABC. ABC. This angle is denoted by theta. It is given that cos theta is given. What is given? Given cos theta is equal to 8 by 17. That is adjacent side by hypotenuse is given. So what is actually the adjacent side? So there are two different methods adopted. First we will go by the reader way of doing it. Adjacent side is 8 and hypotenuse is 17. Not necessarily, because 16 by 34 is also 18 by 17. So suppose this is 16 and this is 34, then also you will get the same ratio, or and so on. Or if it is 48 by 51, then also you will get the same thing, right? Okay, no, 24 by 51. Suppose cos theta is equal to 24 because the side is 24 and adjacent side is 24 and the other one is 51, then also you will get 8 by 17. So it's not necessary that the measurements are 8 and 7. We can take it as 8 and we can take it as 17. To be on the safer side, as per the reader method, we go by the reader method first. So we take the adjacent side a multiple of 8 and hypotenuse multiple of 17, not necessary 8 and 17. Even if you take 8 and 17, you will get the same thing. Okay, 8k, first I will show with the 8k, 13k. In triangle ABC, BC, using Pythagoras theorem, BC, I will write that AB square is equal to AC square plus BC square, or BC square is equal to AB square minus AC square, or BC is equal to root of AB square minus AC square. In fact, it is equal to what? 17k whole square minus 8k whole square. So this is equal to root of 7289 k square minus 64 k square. That is equal to root of 5 to 25 k square, or 225 k square is 15k. So this is a 15. I repeat, this is equal to 15k. 15k. So 17k, 15. You got the side as 15. You have been asked to find all the remaining angles, all the remaining ratios. First one is sin A, that is opposite side by hypotenuse. Opposite side is 15k. Even if you don't write k, you will get the same answer. K cancels here. K cancels. So the answer will be equal to 15 by 17. Cos A is given. Next one is tan A. Tan A is opposite side by adjacent side. 15k by 8k. So that is equal to 15 by 8. Cot A is the reciprocal of tan, 1 by tan A, that is equal to 8 by 15. And secant of A, either you write the ratio, I mean hypotenuse by adjacent side, or you can say that the reciprocal of 1 by cos, not A, all of them are theta. All of them are theta. Cos theta, that is equal, or same as sin A or cosine theta. 1 by cos theta, what is that? 1 by cos theta, 17 by 8. And cosec theta is the reciprocal of what? Sin theta. So that is the reciprocal of this 17 by 15. We calculated all of them. So if you want, you can use k. This is the reader method. Reader suggests using k, and even if you don't use k, you will get the same result. Next one, question number 5. Question number 5. Cosec A is equal to root 10. Root 10. I will say root 10 by 1. What is cosec A actually? Cosec A is equal to reciprocal of sine. So I can say that sin A is equal to 1 by root 10. Okay. So that means opposite side by hypotenuse. So let the opposite side be let the opposite side be 1k or k, and the hypotenuse be root 10k. So we have the right triangle. We call it as put up a larger figure here. This is A, B, C. Opposite side is 1k. Here it is root 10k. We can find AB using Pythagoras theorem. AB square is equal to AC square minus BC square, or AB is equal to root of AC square minus BC square, that is equal to root of root 10k whole square minus k square, that is equal to root of 10k square minus k square, that is equal to root of 9k square, or that is equal to 3 times k. So this is 3 times k. You have been asked to find. So we have the values. This side is k, this side is k, this is 3k and 10k. So we can find out the remaining. What is that? Sin A is available. Which are the things available now? Sin A is available. What is sin A? 1 by root 10. Cosec A is also, its reciprocal is available, root 10 by. Now cos A is adjacent side by hypotenuse. Adjacent side 3k by root 10k, or k cancels, 3 by root 10. If cos A is that, then immediately we can find out what reciprocal secant A, that is root 10 by 3, and the next one is tan A. Tan A is equal to opposite side by adjacent side, k divided by 3k, that is equal to 1 by 3. Therefore, the reciprocal cot A is equal to 3 by 1 or 3. So, we have sine, we have cos, sine, cos, tan, cot, cosec and sec, all of them 1 by 1. Okay. So, now let us take the next question. Question number 6. If sin theta is equal to a square minus b square divided by a square plus b square, find the value of all trigonometric ratios. So, I am just drawing one triangle, naming it as A, B and C. A, B and C. Take this angle as theta. So, we know that sin theta is equal to, given what is given? Given sin theta. So, opposite side by hypotenuse is equal to a square minus b square divided by a square plus b. So, opposite side is a square minus b square and the hypotenuse is a square plus b square. You can take a multiple of k or without k, anything can be done. So, this question for convenience I am not taking k, even if you put a k, no problem. So, AB is equal to root of what? AC square minus BC square. So, that is equal to root of, be careful, a square plus b square whole square minus a square minus b square whole square. So, this is equal to root of a raised to 4 plus 2 a square b square plus b raised to 4 minus a raised to 4, there will be bracket, then I can open the bracket, minus 2 a square b square plus b raised to 4. When I open the bracket, I can cancel these two, I can cancel these two. This will be equal to 2a square b square, negative of negative, plus 2a square b square, that is equal to 4a square b square under root. So, it will be 2ab. This is equal to 2ab. So, you got all the sides. So, measurement AB is equal to 2ab and that is the adjacent side. Now, BC is equal to a square by b square, that is the opposite side, and AC is the hypotenuse, that is a square plus b square, a square plus b square, that is hypotenuse. From this we can find out all the remaining. First one is cos theta, that is adjacent side divided by hypotenuse. You write the steps in detail, I am just telling the next one. Tan theta is equal to opposite side a square minus b square divided by 2ab. Cot theta, reciprocal of this, so 2ab divided by a square minus b square. Secant theta, reciprocal of cos, a square plus b square divided by 2ab, and cosecant theta, that is 1 by sin theta, reciprocal of this. How much is that? That is a square plus b square divided by a square minus b square. Okay, before going to the next question, I will just refresh something. Okay, refresh something, and I just put up few more, 1 or 2 results again. That is, we know that sine of a, this is what we have learned, opposite side by hypotenuse. Cos A is adjacent side by hypotenuse. Tan A is opposite side by adjacent side. Now they are reciprocals, 1 by 1. Cot A is equal to adjacent side by opposite side. Secant A is equal to hypotenuse by adjacent side, and the reciprocal of sine. Cosec A is equal to hypotenuse divided by opposite side. This is what we have done so far. I'll put 2 more, and we have learned the relationship. But what is that? Sin A is equal to 1 by cosec A, or the receive vice versa. And sec A, what is sec A? 1 by cos A. What is cot A? Cot A is equal to 1 by tan A. This is what we have. Now I am going to give you two more beautiful results. That's nothing but what happens when I divide sin A by cos A. That is opposite side by hypotenuse divided by adjacent side by hypotenuse. Hypotenuse cancel. That is opposite side by adjacent side. Let us look, where do we have this opposite side by adjacent side? Here it comes. So what is that? That is tan A. So we get a beautiful result. What is that result? Sin A by cos A is nothing but what? Tan A. Sin A by cos A is nothing but tan A. It's nothing but tan A. Sin A by cos A is nothing but tan A. Okay. Now, this is very important result. One more result. Second result is, what is the reciprocal? Cos A by sin A. It's the reciprocal of tan A. It will be obviously cot A. It doesn't matter, we will see. Cos A. Adjacent side by hypotenuse whole divided by opposite side by hypotenuse. Hypotenuse cancels. Adjacent side by opposite side. What is it? It's nothing but cot A. So we have the one more result, that is cos A by sin A is equal to what? Cot A. Already we have seen that tan and cot are the reciprocal. They are the reciprocal of one another. So tan A is equal to sin A by cos A. Tan A is equal to sin A by. So I'll sum up. Sin A, opposite side by hypotenuse, cos A, adjacent side by hypotenuse, tan A, and so on. Now two more new results. What is that? What happens when sin A is divided by cos A? We get tangent. Cos is divided by sin. We get cotangent or cot. Okay? Clear? So now let us continue with the questions. Question number 8. That is what we have to deal with. Question number 8. Cosec A is equal to find 1 by tan A plus sin A by 1 plus cos A. Seems to be a question having a little bit of numericals. So cosec A is equal to, so what is cosec A? 1 by sin A. So we know that sin A is equal to 1 by cosec A. So this is equal to 1 by 2. So we draw a triangle. A, B, C. This is nothing but what? Opposite side by hypotenuse. So either I can take it as 1K, this is a 1K, or 1 and 2. In triangle ABC, AB is equal to root of AC square minus BC square. So that is equal to 2 square minus 1, that is equal to root 3. So we found out the value of this, which is found out. So I am circling it. Found out. No need of circling it for that exam, just between you and me to understand. So sin A we got. How can I find? So what are the things we need? We need sin A, tan A, cos A. We will find cos A. Cos A is what? Adjacent side by hypotenuse. What is adjacent side? Root 3 by 2. Next, tan A. Tan A is equal to what? Either sin A by cos A or opposite side by adjacent side. Opposite side by 1 by root 3. Using this, what is tan A? Sin A by cos A. What happens sin A by cos A? Look and see. 1 by 2 by root 3 by 2. 2 cancels. We get the same thing. 1 by root 3. So no need to worry. So now we will substitute it here. What is that? 1 divided by tan A plus sin A divided by 1 plus cos A. This is what is required. 1 divided by 1 by root 3 plus sin A is 1 by 2. I believe it is 1 by 2. Yes, 1 by 2. Divided by 1 plus root 3 by 2. 1 by root 3 is equal to root 3 plus, taking LCM here, 2 plus root 3 divided by 2. These two cancels. What remains is root 3 plus 1 divided by 2 plus root 3. Either you leave it here or you can do one more step. Rationalizing the denominator, multiplying the numerator and denominator by the conjugate. 2 minus root 3, 2 minus root 3. So what remains is root 3 plus 2 minus root 3 divided by a plus b, a minus b, that is a square. 4 minus 3, that is equal to root 3 plus 2 minus root 3 divided by 1, that is root 3 plus 2 minus root 3, root 3 cancel, answer is 2. Okay, now we go for question number all the questions are similar questions in triangle question. These are we can do. I'll take one, the tougher ones I'll do. Question number 13. Sec alpha is equal to 5 by 4. Verify. You have to verify tan alpha divided by 1 plus tan square alpha is equal to sin alpha by secant alpha. We have to verify that. Okay. So here in sin, sec, tan and all. So given is sec alpha. What is given? Given sec alpha, that is equal to 5 by 4. So what is sec alpha? Hypotenuse by adjacent side. 5 by 4. You can draw a triangle. Just draw a better triangle. Okay, triangle A, B, C, named as alpha. Opposite side is hypotenuse. Hypotenuse is 5, adjacent side is 4. Obviously, this is use Pythagoras theorem. You will get it as 3. I circled this just to identify that is we found it. Okay, that you can do. BC is equal to root of AC square minus AB square, root of 5 square minus 4 square, 25 minus 16 root 9, that is equal to 3. Now we have to find out the values of, we will be finding the value of 1 by 1 in the sec alpha is given that what tan alpha. How do you find tan alpha? Tan alpha is opposite side by adjacent side, opposite side by, that is equal to 3 by 4. And now we have tan alpha is already sin alpha. Sin alpha is opposite side by hypotenuse, that is 3 by 5. Now we will take the LHS to be verified. Tan alpha divided by 1 plus tan square alpha. Tan alpha is 3 by 4 divided by 1 plus 3 by 4 whole square, that is equal to 3 by 4 divided by 1 plus 9 by 16, that is equal to 3 by 4 divided by, when you take LCM, 25 by 16. So 3 by 4 into 16 divided by 25, 4 times. So this is equal to 12 by 25. So LHS is 12 by 25. RHS. You are asked to prove it as RHS to be proved as sin alpha by sec alpha. What is sin alpha? Sin alpha is given to be 3 by 5 and secant alpha is given 5 by 4. So this is equal to 3 by 5 into 4 by 5, that is equal to 12 by 25. So when you look at the LHS and RHS, both of them are one and the same. Therefore LHS is equal to RHS. Verified. Okay, so question number 15. Question number 15. What is the question number 15? Angle A and B are acute, and so that cos A is equal to cos B. Show that show that angle A, it should be angle A equal to angle B. Show that, yes, show that angle A is equal to angle B. So this is the question. Question number 15. A and B are acute angles, so that cos A is equal to cos B. I'll just draw a triangle. A and B are angles of a triangle. A, B, C, acute angle. So I'll take this as A, this as B. As far as cos A, what is cos A? From the figure, what is cos A? Cos A is equal to adjacent side by hypotenuse. Which is the adjacent side for cos A? Which is the adjacent side, not cos A. What is the adjacent side for this angle? Adjacent side is AC. AC divided by hypotenuse is AB. Similarly, AB. Similarly, we look cos B. This angle. As far as this angle is concerned, the opposite side is, this is the opposite side. So adjacent side is this. So that is equal to adjacent side by hypotenuse. This is adjacent side and this is the hypotenuse. That is BC divided by AB. What is given? What is given? Given that cos A is equal to cos B. What does that mean? What does cos A? AC divided by AB is equal to BC divided by AB. What can be done? What can be done? We have a cancellation. What is that? Beautiful cancellation. AB cancels. AC is equal to BC. These two sides are equal. These two sides are equal. Implies triangle is isosceles. Therefore, what? Their corresponding angles are AC, opposite angle is B. BC, what is opposite angle? A. Therefore, implies angle A is equal to angle B. Reason, angles opposite you, I think you can write angles opposite to equal sides of a triangle are equal. Okay, got it. So the next one. Next question. These are all similar, same type questions coming here. Now, after that, okay, therefore one more verification is there. You can just try one by one. Now, thereafter we have homeworks based on this. I mean, all same type questions, substituting in that. But one question I'll do here. Selected. Okay. This is nothing but just for homework. Question number 19. Question number 19. Given 5 tan alpha is equal to 4, show that 5 sin alpha minus 3 cos alpha divided by 5 sin alpha plus 2 cos alpha is equal to 1 by 6. To be proved as 1 by 6. Nothing new in this. But this question, as usual, what is the usual procedure? 5 given 5 tan alpha is equal to 4 implies tan alpha is equal to 4 by 5. So, in a triangle, tan alpha is 4 by 5. A, B, C or P, Q or this angle is alpha. That is opposite side by adjacent side. Opposite side by adjacent side. This is opposite side. So, you can take 4 and this as 5. We can find out this side. AC is equal to root of 5 square plus 4 square, 25, 16, 35, 41. Root 41. Now you can find out sin alpha, cos alpha and substitute there. Okay, this is our usual, and what we show that it is equal to 1 by 6. This is our usual story. This is the usual story. Usual story. Isn't it? Now we are gonna, what I'm gonna do is that I'm just gonna put a trick here. Not applicable for all questions, but few of them. Such questions can come in the board. Okay, tan alpha is going to be 4 by 5. What you have to do, you draw the triangle, find the usual way. Now, what is the LHS? LHS is 5 sin alpha minus 3 cos alpha divided by 5 sin alpha plus 2 cos alpha. This is to be proved as 1 by 6. In order, the trick is, my questions, I am asking myself a question. Is it possible that I can apply this tan alpha? I know the value of tan alpha. Is it possible that it can be applied directly in the question? For that, I use, this is the trick. Divide numerator and denominator by sin by cos is tan by cos alpha. So what happens? Sin alpha minus 3 cos alpha divided by, I am dividing by what? Cos alpha whole divided by 5 sin alpha plus 2 cos alpha divided by again cos alpha. Will the value change? If a fraction, numerator and denominator both divided by same value, doesn't change. So now I am splitting the numerator. This big, okay, it's there. Now I am gonna take care of this. 5 sin alpha by cos alpha minus 3 cos alpha by cos alpha. Next question onwards you can do it mentally. 5 sin alpha by, I have seen the sin alpha plus cos alpha by cos alpha somewhere. 2 cos alpha by cos alpha. This is equal to 5. What is sin alpha by cos alpha? We have seen that somewhere. Where did we see that? Sin alpha, sin A by cos A, tan. Cos A by sin A, cot. Sin alpha by cos alpha. What is sin alpha by cos alpha? This is, what is this? Sin alpha by cos alpha. It is nothing but what? Sin by cos, tan alpha minus cos cancel. This is equal to 3 divided by 5 plus again sin by cos, tan alpha plus cos cancels 2. So directly we are applying this. When you are doing this, it may sound a little longer compared to this, but in actual calculation this will be shorter. Okay, you try this and see. These steps and all you can do, this you can skip the step. Directly from this you can write here sin by cos tan. Okay. But what is tan alpha? Tan alpha is given 4 by 5. Substituting the value 4 by 5. 5 into 4 by 5 plus 2. So this is 5 cancels. 1 divided by 4 plus 2, 6. That's the answer. So it's very simple to do this way. The thought is how to use tan alpha in the question. Sin is there, divide by cos. Okay, that is the trick. Similar questions may be available. Okay, here also cot A can be found out. Divide this throughout by, I want to bring it cot. What is cot? What is cot? Remember cos by sin. Where is it? Yeah, cos by sin, cot. Remember. So how can I bring cos by sin here? Dividing throughout this question, 18th, divide throughout, take this cot A, divide throughout by what? I need cot. So cot, cos by, divide throughout by cos, numerator and denominator, divide by cos. Okay, so it's very simple. I'll show that if you want. I'll show that. Not detailed, but just quickly. 18. Divide this numerator and denominator by cos A. Dividing the numerator and denominator by cos A. Sin A minus cos A by cos A. You do step completely. I'm just doing sin A by splitting. Sin A by cos A plus cos A by cos A 1. Divide by sin A, oh sorry, we need the other one. Dividing throughout by sin A. We need cot. So dividing throughout by sin A. So it will be sin A plus cos A divided by sin A whole divided by sin A minus cos A divided by sin A. This will be equal to sin A by sin A 1 plus cos A by sin A. Cos A by sin A divided by sin 1 minus cos A by sine A. What is that? This is equal to 1 plus what is cos by sine? Cot A. Cot A divided by 1 minus cot A. Cot A is directly available, 12 by 16. Take it here and substitute 12 by 16, 1 minus 12 by 16, simplify directly. Okay, so that is the homework question, first part. Now question number 21 also I can explain. Tan theta plus 1 by tan theta is equal to 2. Find tan square theta plus 1 by tan square theta. This is asked. What we do is tan theta plus 1 by tan theta square, so squaring whole side, is equal to 2 square, squaring both sides. Now when you look at it, it is of the form a plus b whole square. A plus b whole square. What is that? A square plus 2ab plus b square is equal to 4. What is in place of a? Tan. So tan square theta or tan theta whole square. Tan theta whole square plus 2 into tan theta into what is b? 1 by tan theta plus 1 by tan theta whole square is equal to 4. When you look at this, you can see that this cancel. So tan theta whole square plus 2 plus 1 by tan theta whole square is equal to 4, or tan theta whole square plus 1 by tan theta whole square is equal to 4 minus 2, that is equal to 2. Okay, fine. So now what is asked? Not tan theta, it is tan square theta. This is a very important concept. Please remember that tan theta square is also written as tan square theta plus tan theta whole square 1 by same as tan square theta is equal to 2. So the concept which I want to reinforce here is nothing but what is sine A whole square? Sine A whole square is nothing but sine square A. Cos A whole square is what? Cos square A. Sine square 30 is same as any value. Sine square P is same as sine P whole square. Please be careful that what I am going to tell next. Sine A whole square is not equal to sine A square. A square means that angle is being squared. So remember that sine A whole square is same as sine square A, or sine A into sine A is equal to sine square A. That is square of that a trigonometric ratio. Tan A whole square same as what? Tan square A. We have already used this over here in one question. We have used it without noticing. We have used it because it's a very simple thing. We have used it somewhere. One question we have used it. Here we have used it, tan square alpha. The meaning of tan square alpha is nothing but tan. Here we have used it. Tan square alpha means nothing but what? Tan alpha whole square. See. So please make a note of it.